Hey there guys, and welcome back to my channel. In this video we are going to talk about typecasting. So that basically means changing the data types of your variables just for a moment, or technically just for a statement in C code. So over here what I have done is I have declared two integer variables 15 and 2 and a float variable div, and I'm doing div is equal to x divided by y, so 15 divided by 2, which is 7.5, right? But in this case, since 15 and 2 are only integers, what C is going to do is C can only divide them till integer and then just give that to div. So now the answer will be of 15 by 2 will be 7, because they both are integers. They don't have any decimals associated with them. They don't even understand the concept of decimal. So the answer will be only 7, and div will be equated to 7, and since div is float, it will automatically add after decimal 00000 after it, or 6 zeros after it. So I'll just show that to you. Quickly compile it and run it. And as you can see, you see 7.000. But what if you wanted the proper decimal division over here, but didn't want to change these two float? So like for example, you still have to use them as integer down the line in your program, but over here you just want to use them as a decimal number. So what you can do is you change their types in brackets. So now this will change the x by y to the decimal or float data type, and then it will compute all the decimal values as well. So now the answer will be 7.50000 or whatever, and then it will assign that to div. So time to see that. I'll save this first. Now compile it and run it, and now as you can see, it showed you 7.50000. And now in the previous case, when you saw 7.000, this was basically here like this, and this was an integer number. But since C saw that, okay, this is an integer number and this is a float, and I cannot, and I should store a float number inside a float data type. So what it did is it took this 7, automatically converted it to a float by adding 0.6 zeros after it. So it automatically converted it to a float type. So this is called implicit typecasting or typecasting, which is done by the compiler automatically. And what we did with the bracket over here is called explicit typecasting, or the typecasting which the programmer does. Okay, now you use this a lot in stuffs like I have used this typecasting concept a lot in Java, because in Java what I do is basically when I create a button, a user clickable button, what I do is I get the button, and when I get that button, it just gives me as a graphical component, and I have to typecast it to a button to tell the compiler that it is button. Don't get too much into it. You will see that when we start our Java tutorials, and further down the line you will see that, which will be soon because the C tutorial is almost completed. So anyways, this is typecasting, and I'll show you one more quick little thing. I'll just change this x to 0, and I'll take a char ch, take an input from it, %c, address of ch, and then I'm going to print the sum of them, x plus ch. So adding a character with an integer doesn't make any sense, right? Why would you do that? This is a character, and this is a character, and this is a number. So I'll just show you a confusing thing first. I'll compile this, and I forgot something. I forgot the semicolon. Yep, there we go. And I'll compile it, and I'll add, so remember x is 0, and I will add another 0 to it. It says 48. 0 plus character 0 is 48. I'll do an addition of 9 now. It says 57. 0 plus 9 as a character is 57. And now I'll add small a and small z. So what's going on over here? Why this 48 and 57 and 97 and 22? So what's basically those numbers are, they are ASCII code. So pretty much every key you see on your keyboard has an integer code related to it. Okay? Now those codings are done in two ways, in ASCII and then in what do you call it? Unicodes. Unicodes are different from ASCII codes and they support a larger amount of codes and keys. On the other hand, ASCII codes pretty much supports every key you see on your keyboard. And Unicodes have some more special characters in them too. If you want to experiment with ASCII codes, what you do in Windows is you press the Alt and you, from the numpad, type any number, and it will basically be the computer will interpret that as an ASCII code of that number, and then it will show you the key related to that ASCII code or the number you entered. So say for example your small a key does not work in Windows. So what you can do is you can just press Alt and from the numpad type 97. It will interpret that ASCII code as small a. So that's what you can do. In Linux, for example, I'm using Kubuntu over here. Kubuntu uses Unicode, so I saw on the internet it was not working for me. I saw that on the internet they said that you have to type Control plus Shift and then the code Unicodes. It didn't work for me. I don't know why. You might try and find it yourself. I didn't dig into it that much because that's not really important. What important is that you understand the concept of ASCII codes and Unicodes. So basically, what are these ASCIIs and Unicodes? They are basically codes which relate to your keys or pretty much any character in the computers. So, say for example, the A to Z over here has the ASCII codes of 97 to 122. So, small b will be 98 and C will be having the ASCII code of 99 and D will be having ASCII code of 100. So I will prove that to you. I will not save that because that's an error. I'm just gonna compile it and enter B, 98, enter D, it's 100. And if I type capital A and capital Z, so these are different. So capital letters are different from small letters, and hence they're different ASCII codes. So now capital B will be 66, capital B will be 66, capital B will be 68, so on. And then if I type say a hash, even it has an ASCII code of 35. If I type exclamation mark, it has an ASCII code 33. So this is your ASCII code. So whenever you type a key on your keyboard, what's going on over here? Say for example I type small a. So the keyboard sends the computer an input of its ASCII code or Unicode, whatever your operating system is using. So in this case it sends the ASCII code, and then the computer will read that ASCII code and say that it's come from keyboard, so it knows that it has to be a character. So it will read that ASCII code. Okay, 97 corresponds to small a, so it will print you small a. So that's what these ASCII codes are. Each key has an ASCII code related to it. You can find a proper chart on the internet for the ASCII characters, which tells you what the ASCII code is and what the character they correspond to. Similarly, you can find a chart for Unicode online, and that's pretty much it. So what happens over here is this ch, when we add this x plus ch, this ch gets changed to its integer value, basically it's ASCII code. So when I type small a, this ch over here gets changed to 97, and computer does then see 0 plus 97. So you see the 97 over here. So basically it automatically typecasts it to its ASCII code. So I'll just do one thing, and instead of adding them, I'm just gonna print the character, and I have to remove this, save it, and quickly compile it and run it. if I type A right now, it's gonna give me 97. B, okay, I made a mistake. B, 98. So what's going on over here is I have said that give me an integer in the output, but I have given over a character over here. So see what it does is it says that I have to output an integer no matter what. So what I'm going to do is I'm going to change this ch character to integer and then print it. And this character value for integer, and if you change the character to integer, you basically get their ASCII values. So that's what's going on over here. It's typecasting the ch to an integer, and in this case the integer corresponds to their ASCII values. So that's what typecasting is, and this is what the ASCII codes are. And I hope you get everything. If you don't get anything, just please leave that in the comment section below, and I will be happy to help your doubts and clear them. Please subscribe to my channel. There will be a lot more useful stuff in the future for programmers and even for beginner to intermediate programmers. I will do some stuff like some tips and tricks you can go do using your code if you don't already use them. So anyways, thanks for watching guys. I'm gonna end this video here. Goodbye.